find the directional derivative of this function at this point in the direction of this vector. Okay, so before I walk you through the solution, I wanted to point out that there are only 5 days left in the Maths Countdown series. So we are rapidly approaching the end of the countdown, so make sure you stick around to see what I'm counting down until. Okay, so the first thing that we need to do with the directional derivative is have our formula and see all our unknowns that we need to work out so we can just plug them in. Okay, so the directional derivative in the direction of u, this is a general formula here, at a, b, and c is going to be equal to the gradient vector, and this is the nabla sign. It's basically an upside down delta, or it's a upside down triangle, and that's at f of f at a, b, and c, and that's, we do the dot product with the unit vector u. Okay, and this unit vector is in the direction that we're trying to find this directional derivative. So what do we need? Well, we're trying to find this. So we need these two, and both of those are vectors. So the unit vector is simply this vector unitized, and this gradient vector, we'll get to that in a moment. So first, let's solve for this unit vector. So we know that u is going to be equal to this vector v divided by the magnitude of v, and this formula basically unitizes it. So we're taking v and dividing it by its magnitude, so that now the new magnitude of this vector will be 1. Okay, so the vector v is 1, 0, and 1, and we find its magnitude by taking the square root of v dotted with itself. So v dotted with itself is 1 squared plus 0 squared plus 1 squared, and that goes to the root of 2. So our vector is then 1 over root 2, 0, 1 over root 2. Okay, so we found u. Now let's go ahead and find this gradient vector. So the gradient vector, and let's use our specific points now because we actually have them, pi by 6, pi by 4, and pi by 3, is equal to the vector containing the partial derivatives. So that's fx, fy, and fz. And these partial derivatives are evaluated at these points, or at this point. Okay, so let's then work out the partial derivatives. So the partial derivative of x at that point there is going to be, so first generally the partial derivative of x. So if this is our function, then we're differentiating simply in terms of x. So the derivative of sine of x is cosine of x. And all of this comes along for the ride because we treat those as constants relative to x, because we are now differentiating strictly in terms of x. So anything that's non-x, we treat it as a constant. So that's times by cosine of y and tan of z. Okay, and then if we evaluate it at these points, then for x we're going to substitute in pi by 6, for y we're going to substitute in pi by 4, and for z we're going to substitute in pi by 3. Okay, so cosine of pi by 6 is cosine of 30 degrees, and cosine of 30 degrees is root 3 over 2. And that's multiplied by cosine of y. And cosine of y is cosine of pi by 4, and cosine of pi by 4, cosine of 45 degrees, and that's root 2 over 2. And tangent of z is tan of pi by 3, and that's going to be root 3. Okay, so the way that I remember all of these, I know it's not exactly particular to this video, you could go and put them in your calculator, but I just thought as a side note, the way I remember these values is I know my trig special angles in terms of degrees, so not radians, and obviously this here is radians, so I'm needing to convert it in my head. So I know that pi by 6 is 30 degrees, pi by 4 is 45 degrees, and pi by 3 is 60 degrees. And I know that cosine of 30 is root 3 over 2. I know cosine of pi by 4 is cosine of 45, which is root 2 over 2. And then I know tan of z or tan of 60 degrees is the same as sine of 60 degrees over cosine of 60 degrees. Sine of 60 degrees is root 3 over 2, and cosine of 60 degrees is 1 over 2, and root 3 over 2 divided by 1 over 2 is just root 3. So that's a process that I go along to solve these special angles, trig ratios at special angles, so that I don't have to remember as much. So I just thought as a side note that might be useful to you. Okay, so now let's do the partial derivative, and of course still the same points of y. So now the partial derivative of y. Okay, so now we're simply deriving in terms of y. So this sine of x and this tangent of z are both constants with respect to y. So they just come along for a ride as a constant or coefficient. Okay, so the derivative of cosine of y is negative sine of y. So this is going to be negative sine of x. You can see that comes from there, times by sine of y, times by tan of z. Okay, and if we evaluate this now, I know sine of x at pi by 6 is 1 over 2, so we have negative 1 over 2, and sine of y at pi by 4 is root 2 over 2, and tan of z at pi by 3, we evaluated it here to be root 3. Okay, so now we need to do the partial derivative of z. Okay, so fz, and of course still at the same coordinates, and so with respect to z, our sine of x and cosine of y are constants, so we can leave those, sine of x and cosine of y, and then our tangent of z is what we're deriving. The tangent of z is secant squared of z. Okay, so if we evaluate this at these points, we know that sine of x is going to be 1 over 2. We know that cosine of y is going to be root 2 over 2. And we know that secant squared of z is the same as 1 over cosine squared of z. And cosine of z is cosine of pi by 3. And cosine of pi by 3 is cosine of 60 degrees, and that's 1 over 2. So we have 1 over 1 over 2 squared, which is the same as 2 squared, which is 4. And that 4 will cancel with that 4 over there. So 2 times by 2 in this denominator divides 4. Okay. So now we have our gradient vector. And our gradient vector is simply going to be of f. And I'll omit these coordinates again in the sake of time. So it is root 3 times by root 3, which is just 3. So it's 3 root 2 over 4. This simplifies to negative root 6 over 4. And this is just root 2. Okay, so we have the gradient vector now, and we have the unit vector that this directional derivative is going to be in the direction of. So we now just need to do the dot product of this vector over here and this vector over here. So let's copy this vector, and we'll paste it down here. And we'll copy this vector and paste it over here. And now our goal is to find this dot product. So we have 1 over root 2 multiplied by 3 root 2 over 4. The root 2's cancel, and we're just left with 3 over 4, plus 0 times by this component, which is of course going to be 0, and then plus root 2 over root 2, which is just going to be 1. And then we have 3 over 4 plus 1, which is 3 over 4 plus 4 over 4, which is 7 over 4. And that is then the directional derivative of this function of x, y, and z evaluated at this point in the direction of v. So I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.